how are fingerprints analyzed and compared? So the system we use is called ACE-V, and ACE-V is a 4-step process to identify and individualize a fingerprint. The first step is analysis. This falls into two subdivided processes. First is the primary pattern classification. So this is looking at the very general pattern that we can see in the fingerprint. Those are loops, whorls, and arches. After we've done that, we analyze the ridge characteristics, also called minutiae. These are things like ridge bifurcations and ridge endings, and we'll talk about this in more detail momentarily. Then we do a comparison. So we compare the question fingerprint to the candidate fingerprint. The fingerprint that we found at the crime scene, for example, to the fingerprint that we've taken from the suspect. Then we do an evaluation. We say, is this a match or is this not a match? And then finally we call in a second examiner to take a look at the fingerprints and see whether they agree with us that it is a match or it is not a match. So we have a second person to verify our findings and confirm that we've done our work correctly. That's the ACE-V system. So we said in the analysis that we do a primary pattern classification, then we look at the ridge characteristics. Let's take a look at that primary pattern classification first. So what are the 3 general ridge patterns of fingerprints? How do we distinguish them? First of all, we have loops. So this is a nice example of a loop type fingerprint. And what I hope you can see here is that we have a central core, which has been labeled, and the lines circle around it. They enter at the lower right part of the image, they circle around this core, and then they exit at the lower right part of this image. Let me say that again, and really try to follow along with your eyes. These lines enter the picture at the lower right of the image, they circle this core, and then they exit at the lower right of the image. Now, on the left side of the image, you'll see another characteristic of loops, which is a delta. So you can see that on the lower left, you have a set of lines coming in that diverge, and then these lines go around that core structure. And we call this divergence a delta. So all loops will have exactly one delta. And these lines that then go around the core, we call type lines. So this is one of the first patterns. This is the loop. We also have whorls. Here's a whorl. So in contrast to loops, which have only a single delta, here I think you will be able to recognize not one, but 2 deltas. So you'll see on the lower left area, middle lower left, 1 delta, and then you'll see that core in the middle swirling around, and then you'll see another delta on the right side of the image. And these 2 deltas, that's characteristic of a whorl pattern. And there are a couple different types of whorls. This one that you're looking at right now is a plain whorl, but that's what we'll stick to for now, and we can elaborate on this later if we need to. Finally, we have arches, and there's 2 types of arches. Figured I'd show you both because they're pretty simple. An arch is just basically a little bit of a wave in the ridge patterns. We have a plain arch, which is more of a gentle arc, and then we have a tented arch, and the tented arch is just more of a sharp pattern, less than a 90-degree angle, if you like. So that there's a 90-degree angle, tented arch would be somewhat less than that. So those are the 3 types of general patterns. We have loops with single delta, whorls with 2 deltas on either side and the whorl in the middle, and we have arches, which are just sort of waves, either pointy ones, which are tented, or smoother ones, which are plain. So once we've analyzed every fingerprint that we've taken from somebody in terms of whether it's a whorl or a loop or an arch, we can do what's called a Henry primary classification. And this is just an initial way to look at the fingerprints. It's not final. So what happens is we give each set of fingerprints a number based on the number of whorls in the fingerprints. We could have done it based on loops or arches or whatever, but we just picked one of the patterns. And so if you have 3 out of 10 of your fingers are whorls, and those whorls are on your right thumb and your left index finger and your left pinky, then you'll have 1 number. And if somebody else has 3 whorls as well, but they're on different fingers, then they'll get a different number. Another person has 7 whorls, they'll get a different number. So there's a different number given to each possible combination of whorls or no whorls. And so that's a unique number for each of those. So what we do is we take this primary classification that just tells you basically how many fingers have whorls and which fingers are they, and then you can check that against the database, and then you can exclude anyone who doesn't have those general patterns. Because we know that if I have a whorl on my left middle finger and the person you're checking me against doesn't, then you don't need to go any further. You know that person isn't me. So this is just like a first sort of rough estimate. This is easy to do. Even pre-computer, you can do this pretty fast. It reduces the load today on databases, so you can sort through things more quickly. And so what you end up with is the results from such a comparison would be a bunch of matches that have the same general pattern on every finger. So all of the matches that are returned, if your suspect that you've brought in and fingerprinted and submitted to the system has a whorl on his left thumb, then all the returned patterns will have a whorl on the left thumb. If your suspect does not have a whorl on the right finger, then all of the matches returned will not have a whorl on the right finger, and so forth. Now, this is not enough for a match. This is absolutely not enough for a match, but it is enough to exclude a number of possibilities. In order to have a match, we have to look at the ridge characteristics. So let's take a look at that now. What are the details of fingerprints that can be used to identify a person definitively? These general patterns are useful, but they're not enough to definitively identify somebody. So, ridge characteristics, let's take a look. The final identification of a person is based on the ridge characteristics, which we can also call minutiae. Either term is fine, they're both commonly used. What are the types of ridge characteristics we look at? We have bifurcations, this is where a ridge splits in two. We have ridge endings, this is where a ridge, ends. We have enclosures, this is when a ridge splits and then rejoins, looks like this. And we have ridge islands. These are very short, isolated ridges. Sometimes they look like dots, sometimes we just call them short ridges because they appear and then they stop right away. Most APHIS systems focus on bifurcations and ridge endings, I think just because they're the easiest to discern. So let's take a look. So here you can see in this image a number of ridge endings, bifurcations, and enclosures. So let's take a look from the labels that start on the left side and work our way around clockwise. So you'll see on the left side it says ridge endings, and you can see the arrows point to some places where indeed some ridges have ended. So there's some ridge endings. Then we continue in a clockwise fashion. We can see a first bifurcation. So there you can see that a friction ridge is coming from the lower right, and it's coming up, and then when it hits the area where the arrow is pointing, you can see the friction ridge splits into two ridges. There's your bifurcation. Continuing clockwise, we see another ridge ending, which is just the ending of a ridge. Continuing clockwise, we can see an enclosure. This is basically a bifurcation followed by a coming back together, a unification of these ridges. Continuing on clockwise, we can see a ridge island or a ridge dot. This is just a single very short ridge. And then at the bottom there, we can see another bifurcation where the friction ridge splits. So what I've done here is I've taken two fingerprints and marked with red dots each of these ridge characteristics. And there are many more ridge characteristics in these images, but we only need a certain number of them. So I thought I would just focus on those ones there. So you can see number one, these are the same fingerprint, by the way. The one on the left is an inked fingerprint that was taken at the police station. The one on the right is a latent fingerprint. This was dusted and picked up. You can see, by the way, that the latent fingerprint is pretty low quality compared to the inked one. So there's some difficulty there. So you can see the first one labeled in number one, that's a bifurcation. You can see that. Number two is a ridge ending. Number three marks out an enclosure. Number four marks out a ridge ending. Number five is a bifurcation. Number 6, 7, also bifurcations. 8 is a ridge ending. 9 is a ridge ending. 10 is a short ridge. 11 is a bifurcation. And 12 is a ridge ending. Now might be a good time to pause the video and make sure that you can see each of these items in, I would say the leftmost fingerprint would be the place to focus because this is the easiest one to see. So go ahead and pause the video and just make sure that you actually can see the bifurcation wherever there's a bifurcation, that you can see the ridge ending wherever there's a ridge ending. This takes a little bit of practice, so please pause the video for a moment or two and see if you can find all these things and see them for what they are. Are you back? Did you do it? I hope you did it. If you didn't, go do it now. But if you did, let's keep going. So on the right side of the screen, you can see the latent print which was pulled from the crime scene. And you can see that all of these 12 characteristics, bifurcations, ridge endings, enclosures, short ridges, are present in that one there on the right. Now it's a little harder to see them, but they are there. And one of the things that I'd like to draw your attention to, the reason that I added these red dots, is so that you can verify that not only are all of these characteristics present, but they're present in the same pattern. So if you look at the pattern, sort of try and ignore the fingerprint underneath, and just look at the pattern of the red dots on the left. Now look at the pattern of the red dots on the right. If I did my job correctly and I put the red dots in the equivalent places, then you'll see that the pattern is exactly the same. There's no difference in the pattern. The angles are the same, the relative distances between the dots are the same, and this is what we must have to have a definitive match of two fingerprints. And indeed, what we have here is 12 ridge characteristics in exactly the same places, exactly the same relative to one another. This is a match. So whoever this leftmost fingerprint belongs to, that person left this fingerprint on the right at the crime scene. It doesn't mean they did the crime. It just means that their fingerprint was